I'm John Janowicz. I'm Executive Director of ECEDHA. Thank you for attending this industry spotlight. We have today Digilent Corporation and Clint Cole, who is President, who will be presenting hands-on analog design for every student. Clint?
Thank you, John, and good morning. And I'd like to say thanks again for getting up early to come listen to us. I appreciate the chance to address all of you, and maybe in the next 20 minutes we can figure out how to improve engineering education between us. So I'm going to give you a little view of what we see some of the challenges as and how we intend to kind of drive some of the solutions. Figure this thing out here. So our proposition at Digilent is that every student should complete a significant hands-on design as a part of every assignment. And we've adopted this acronym, which is easy to recognize, easy to remember. It's easy. Every student, every assignment. And we think that's really the key towards improving our engineering educational system. To make it more fun, more compelling, give students broader skills, more knowledge, more self-confidence. And I'll talk through that as we go on here. There's several components to making that real. If we really want every student to do hands-on design as a part of every assignment, well, that's a tall order. And there's got to be some systemic things in place first. First of all, to make it be every assignment, they have to have hands-on, kind of ready-to-go design kits they can take home with them. It's not going to be feasible or real to get that many students in labs often enough to use the equipment that the university's purchased to do these kinds of experiments. We've got to deploy hardware so they can work at home, in cafeterias, in the library, wherever they want to work. We've got to have always available materials online. Yeah, most students tend to work between, 9 p.m. and 3 a.m., and you can post your phone numbers if you want to, or we can put materials out there so they don't have to contact you to help them be self-sufficient, self-reliant. We need to make sure all the software they use is no cost to them, and we can do that by partnering with some industry-leading companies to help encourage them to put free student versions out there, and that's largely the case now, but there's still some nuts to crack there. And we want to also give lots of support to these guys. So again, if students are stuck at 2, 3 in the morning, I guess I wouldn't be up then either, but online resources and forums and community-based resources to help them make progress even after hours. So at Digilent, we have design kits that we're developing and now selling to address the major areas in electronic and computer engineering, electrical computer engineering. We have digital kits that have Xilinx FPGAs on them, and the Basis 2 there behind me is our low-cost entry. For $49, you can get a circuit board that's perfectly capable of holding microprocessors, custom microprocessors of a student's own design, or MP3 decoders, or video codecs, or just a wide variety of circuits. $49. And on the web right now are the beginnings of a free textbook, projects, exercises, hundreds, literally, reference designs that work on this board. $49. That's what, McDonald's? Maybe? Guess I don't go out to McDonald's. maybe it's Denny's. We have microcontroller boards as well. $26 for a chip kit board. That's a new board we developed in conjunction with Microchip. Got a 32-bit MIPS processor on it. Plenty of memory, RAM and ROM, external resources. For $26, you can do a lot of embedded processing. And what I'll spend most of today talking about on the far right there is the analog kit we're just coming out with. Now, that was kind of the harder nut to crack. It's traditionally more expensive, more difficult. It took us a longer development cycle to come up with a truly, I think, breakthrough analog product, and we couldn't have done it alone. We had Analog Devices helping us, and I'll talk more about that here in just a second. But we have kits for every brand of student, I guess. And our goal is to serve the first couple of years of education. We really want to get low-cost kits out there so the freshmen and sophomores can not just do the exercises at the back of the book, not just simulate the designs, but actually get their hands on and do meaty, weighty designs. That's our target market the first couple of years. So student-owned kits need to have a couple characteristics. They've got to be complete, self-contained, ready to go out of the box with free CAD tools. You can't have them going and buying accessories all the time and oh yeah, that cable wasn't there or that part wasn't there. USB powered is important so they can work wherever they want to be. They don't have to have a wall plug. Want to make sure all the IOs are short circuit protected and ESD protected. Want to make sure the kits are current so they're not using things that feel like they're 15 or 20 years old. We want to advance the kits with technology. At the same time, we want to keep them stable from year to year so that you guys can centralize on them and not have to worry about changing curricular approaches every year or two. Low cost, design for students, kind of the same thing, but when we design these things, we don't want to design industry-capable demo boards. We want to design boards with features designed specifically for students. And we think through what their assignments are going to be and make sure the features are there to support them. Free, frequently updated materials to keep everything current and to keep your instructors and your professors from having to reinvent curricula. We're going to do that as well. We're going to keep a big library of current and ongoing materials that you guys can draw from so that there's no going back to the drawing board every semester and recooking things. And again, the fast and competent tech support. But it's not just about the kits. We need robust online resources. These are a couple of screenshots from what's currently posted. In the middle there, the big section in the middle, shows our analog or evolving analog design page. And those links go to the chapters of a free textbook that's posted right now. It's about 600 pages, very well written, I think. There are exercises, the typical homeworks. There are lab projects. There are lecture notes. So when we did the lectures, we used partially complete PowerPoints. The guy doing the lectures fills out the PowerPoints on a whiteboard kind of thing. Actually, it's a big TV. And the students take the same notes, so they can't sit there passively. They've got to annotate their notes as well to try to keep them involved. And then, most importantly, there are video lectures, 40 of them, all university quality, the same thing you'd see in a Circuits 1 class. And we want to evolve to where we have that same presentation for all of the topics, digital design, microprocessor design, and analog design. Other pages have reference designs. As mentioned, there's hundreds of them out there, and other text and backup material. Mentioned we're not doing this alone. We've worked with Xilinx for quite a while. We've worked with Microchip for quite a while. And we've put a lot of kits out there. We have over 200 educational products. Many of those are in kit form. They're all low cost. We've produced over 500,000 of them, and we're in 90% now of the world's top schools, which would include, of course, all of you guys. And we're in 1,500 schools, or actually more than that now worldwide. The tough part was analog design, where the physical world meets the digital world. And we've only recently kind of made some progress there. And again, it's because of our partnership and the assistance we've received from Analog Devices. That's let us take the steps we've taken recently. Now, Analog Devices, I'm sure you guys all know who they are. But just a couple of things to point out. They're number one in data converters. They're number one in high-performance amps. $3 billion last year, so they're a powerhouse. And they spend 17% of their money every year evolving research and development. That's a large number, even in the high-tech industry. So they're committed to innovation, to creating new products, to kind of staying at the front of the envelope there. In fact, they are a world technology and innovation leader, and they're recognized as such, and we recognize them, and we were thrilled to be able to work with them because of pretty much their sterling reputation. And it turns out that we've learned in the last several months that they have a strong commitment to you guys, to education. So they're kind of an ideal company to work with to help innovate in this area, to bring analog design into the hands of students everywhere. Clearly, there are some issues we're all facing. Enrollments are down, up a little bit this semester, but they're down in the last 10 years. Attrition stays high. There's more tools, more skills we got to teach these guys. Funding models are, I don't know about your schools, but I teach at Washington State University, and I think challenging is a good word. We keep losing money to the business school and other folks. And it's getting harder for me anyway to find skilled TAs. So I'm having to spend more time in the lab myself. Not that there's anything wrong with that, but it's getting harder to find those guys. A lot of press lately. Lectures, homeworks, tests, not so effective. The current teaching model we've used that we all went through is kind of showing its age. It's a new era. There's new tools, there's new methods. Students have different expectations, and I think we need to evolve to meet them, to work with them. Mostly we have to get them more involved. That's our job. We've got to make these guys feel challenged and stimulated. And I think the way to do that is to give them real hands-on design always. So they're feeling like they're doing something, making progress every lab, every day, every week. Make it more fun, make it more challenging, more relevant, more fun. We showed a couple of years ago that when we give students kits, they just do better. We did a study at Rose-Hulman. We asked them not to change anything, just give them a kit, see what happens. Oh, did it do its thing? I don't know why it does that. When we gave them a kit, didn't change homework or anything, we found they learned more, they learned better, they learned faster, they enjoyed it more, they scored higher on tests, they did more assignments and more challenging assignments, and they used fewer resources, and mostly they liked it more. Nothing changed. We just gave them kits. We didn't change the homeworks, didn't change the tests, just gave them a kit. Proves that these guys are self-selected. If you give them the opportunity, if you give them the tools, they will take advantage. And they do amazing things. It's kind of fun to watch these guys, and when they realize in the first couple of weeks of class that they have the skill, they have the knowledge, all we had to do is give them the tools to express themselves. When they work outside the lab, we've shown they use the tools more frequently. It's a low-stress environment. They're not in the lab next to students with bright, shining lights. They're unstressed. They can take 5 hours if they need to learn a topic. They don't have to show the guy next to them that they're capable and just get out of the lab and on to the next thing. They have to teach themselves. They have to dive into the help screens. They have to challenge their assumption. They have to do little simulations along the way. And they learn when they do that, and they don't burden the faculty and the TAs to the same degree. You can save the labs. We're not asking you to replace equipment. You guys have all invested in labs. Keep them, use them, but populate them with students that have gone through some more basic training, I guess. So when they get to the labs that are a little more precious, a little higher end, they have skills, and they're better consumers of the equipment, and they can focus on the problems they have with faculty and higher interaction, and just less bodies in there to take those precious lab spaces. The costs go down across the board. Lower costs for students. Our kits are cheaper than a textbook, and the materials are posted for free. If the materials aren't there, we're going to work with you guys to get them as current as we can. Our goal that we're working towards very rapidly is to have a living, breathing resource that we all contribute to keep the materials current. And if anybody wants to customize them or modify them, change them slightly, we're going to work with you. We'll give you the source files. We'll help you personalize the materials to be your brand of teaching. And hopefully the whole community can take advantage of that. We'll keep it going. Keep it living. Keep it growing. Again, free CAD tools. And because all the kits are distributed and they're in the homes of students, there's no equipment for you guys to buy. So the institutional cost goes way down. And we keep our kits current. As mentioned, we advance with technology, but we don't wholesale change things. There are iterative steps. As there's new devices, new technologies, we'll iterate our kit, but the body of the academic materials stay constant. Now, here's what I really wanted to talk about, our newest product, the Analog Discovery. You can come see it at our booth upstairs. We'll have some demos running, and I should have brought one with me. Anybody bring one? Good man. It's a small, self-contained instrument. You can see the specs inside here. It's real. It works. It's late in its beta stage now. We're heading towards what will be the final version of it. It's got a 2-channel, 50 megasample, fully differential scope front end, 14-bit converters, plus minus 20 volts. It's got 2 arbitrary waveform generators, also 50 megasample, also 14 bits. The waveform, I'll show you the software in a second, but the waveform generator can do all kinds of fixed waves and also user-defined waves. 16 digital channels, a couple fixed power supplies, and it's all USB powered, so you don't need anything but this. And you put your lead wires in here out to your breadboard circuit, and it's only $99. There's some great technology in here. Some of the better converters for the ADI operas are on this thing, and the performance backs it up. I'm kind of excited. I hate to leave this slide. I'm kind of excited about it. The free Waveform software runs it. This is posted right now online. Anybody can download it, always free. It uses a high-speed USB port to move data between this and the PC, and the result is that your display looks like a real scope display. It updates as frequently. There's no sense of an instrument causing, the PC causing any lag. Free tech supports all Windows. We're working on Linux right now. Give you a couple screenshots here to show you what's going on. The scope GUI looks very much like a scope. It's got time-based control, channel control, zoom, pan. It's got cursors, measurements, everything you'd expect from a regular scope. But it's got more than that. It's got a full-time FFT on all the traces all the time. So you can look at both time domain and frequency domain simultaneously all the time. Does XY plots in real time all the time. It's got some filtering options on the displays to clean up some noise. It links to the PC's audio system. Great source for signals. You can pipe through WAV files and filter them or do little effects on them. And it's got a very robust database behind it, so that it's the PC with virtually unlimited storage, and we take advantage. So if you're doing measurements over time and you thought, I just saw something kind of cool 3 or 4 minutes ago, well, you can go back and find it if you want to. So it's sort of I think, the best of a low-end oscilloscope and the best of a PC combined. And we know these guys need to create lab reports. So we put the data files in a source that's easy for them to consume and import into their other tools. Waveform generator, yeah, pretty standard looking. This is the basic interface I'm showing you here. So defining sines, triangles, square waves, very simple. You can use these sliders to set frequency and duty cycle and all that stuff. Or you can import CSV files or files from an Excel spreadsheet to define your own waveforms. You can use a captured scope waveform, pipe it back through the waveform generator, PC audio files. Lots of options to get very challenging and robust. There's noise generators, all kinds of stuff out there to challenge the circuits. The digital side, we've got a logic analyzer and pattern generator. Nothing special here. It's kind of what you'd expect from those instruments. It is special. I shouldn't say nothing special. It's a very special instrument. But it's got a very conventional and common set of controls. And you can also use it as a digital I/O trainer if you want to. You can hook the digital signals to virtual buttons and switches and LEDs on the PC, and then you can use this thing to hook into a conventional breadboard if you want to and drive your 7400 logic and sort of do basic logic experiments without having to buy an I/O panel. Cross-instrument functions, it has a good Bode plotter feature, so if you build your first little couple of amplifier circuits, you can get magnitude and phase plots. It goes over 10 decades. It does standard Nyquist or Nichols coordinate systems. You can trigger the scope from the analyzer from the pattern generator. All the instruments cross-trigger, so you have a very rich way of controlling acquisitions. Again, all the data files are standard formats, so you can go in and out of various tools like Excel or OpenOffice or MATLAB or Scilab. There's a whole host of things we can go in and out of. You can save workspaces, so a TA or you guys can set up some compelling demonstrations, like a diode curve tracer the night before. Come in, hit a button, and just show the thing. So you're not explaining in whiteboarding anymore. You can actually show a live demonstration in front of the class and make sure it all works, and just come in and turn it on. Automated web updates and automated troubleshooting as well. And again, lots of online resources. This is a screenshot of the Analog Devices University page. There are links here to find the hardware. There are links here to find the evolving textbooks that we're writing, as well as the projects, the videos. It'll all be through this portal. And if you go through this portal, you get the full power of Analog Devices. They've got 20, 30 years or more of technical articles, of theory of op, of application notes, all of which will be relatively easy to find from this same page. And they're going to support helping students acquire analog devices, technologies, and tools. So it'll be a great portal for online access to engineering stuff. At Digilent Inc., we'll have a portal as well. Parts kits ranging all the way down to under $10. So if you get the Analog Explorer, you can readily accessorize it. In fact, I said the Explorer. This is our next product. It's coming a few weeks, maybe a couple months after the discovery. This one's all self-contained. It also has a solderless breadboard. All of the instruments are accessed by putting jumper wires in these holes. So you literally need nothing else. You get a parts kit, you get this thing, and build your circuits, instrument them, drive them, complete self-contained. This will have 4 single-ended scopes, 100 megasample, 2 waveforms, 100 megasample as well. This has programmable power supplies, up to 30 watts of programmable power supply. From 0 to plus 12, 0 to minus 12, full current control, full voltage control, a very powerful piece of equipment. It literally replaces a stack of equipment this high on your desktop, $199. Okay, the main point, what I really want to sell you on, student-owned kits. It's better for the students. We've proved it. It just is better for the students. It's less expensive for you guys. Lower overhead, lower maintenance, easier for instructors, proven effectiveness, available now Why wouldn't you do it? Why wouldn't you have all your students go get kits for their entry-level classes? I don't even care if you get them from us. That's not the point. Well, kind of is. No, not really. The point is the students benefit, and we should be doing that. Stronger students, they have more knowledge, more skills. Don't replace your equipment, augment it. Make stronger students. Make better consumers of the labs you've already built. Adopt and expand our materials with us. Build a culture of success. And most of this is kind of corny, but I couldn't resist last night in the plane. Mostly, let's make education more relevant, more vital, and more fun. All right, they're going to kick me out. Thank you. Come see us in the lab. Love to talk about this all day. We'll see you up there. Up in the thing there.